Hey y'all, today we are going to take a step away from triangles a little bit, um, and we're going to look at circles again. A little while ago we talked about circles. We talked about different types of segments that would interact with circles, and one of those segments that we looked at were called tangents. Tangents are segments that touch a circle in one place and then never intersect with it again. So here I have a tangent segment. I have a bunch of segments in here, but we're going to focus on these ones. Intersects the circle at that point and we'll never touch it again. I have another tangent segment, intersects the circle, and we'll never touch it again. If we extended this out, it would go on and on forever, never touching this circle again. And so in previous lessons, we talked about what would happen with the angles and the arcs that are formed by these two tangent segments intersecting here outside of the circle. And so now what we want to do is look at what's the relationship between the lengths of these tangents if we measure them. And the relationship that exists when two tangents intersect outside of a circle like this is that they are equal. I'm just going to write equal. They'll be the same length. If we could get a ruler, if we took a ruler and we measured those, they would be the same exact length. And so here we have these two tangent segments and they both have expressions on them. And so we are in the business of using relationships to write equations and using those equations to find missing pieces. And so what we want to do is use the relationship that these two tangents are equal, and we want to write an equation that says so. So I'm going to say this segment 2 plus x is equal to this segment 2x minus 2. Because they're both tangents and they intersect here, and then we can just solve this equation. I'm going to subtract x from both sides, add 2 to both sides, and find that x is 4. So maybe the trickiest thing here is getting yourself back into the habit of solving equations. So again, when I have two tangents, I know that they should be the same length, so I can write an equation that says they're equal. 17x minus 2 should be equal to 1 plus 16x. And one strategy I used for solving equations was moving all the x's to one side and all the regular numbers to the other. So I can move my 16x over here. When I do that, it turns from positive to negative. This stays positive. I can move my minus 2 over here. It turns into a plus 2. So I have 1 plus 2. 17x minus 16x is 1x. And 1 plus 2 is 3. So I want you to go ahead and use that idea to write an equation here and then solve this for x. Pause the video, take a second to try this, and then press play for the answer. So hopefully you set these two equations equal to each other, or expressions equal to each other, to make this equation, because these are both tangent segments that intersect outside the circle. When you solve this, you should get x equals 3. If you're stuck on any of this, of course, you should raise your hand and make sure you ask me for help before moving on so that we can clear up any mistakes, or I can elaborate a little bit on this for you. There's another relationship that exists when we have tangents and when we want to talk about how long the segments are, and that is whenever we have a tangent. So here I have this tangent, and we have a radius or a diameter, like this one. This is a radius because it starts at the center and goes to the circle. We create right angles. And so I guess I lied a little bit when I said we were going to move on from triangles, because I have a right triangle here that exists, and I can use this information that when I have a tangent, it makes a right angle with a radius or a chord. A diameter. And so what we can end up getting here is right triangles. You need to remember that always a radius is the same for every circle. So if one radius is 12, then this radius is also 12. And so that means that this whole side of my right triangle, the hypotenuse, is 20. There's a few ways we solved for missing sides in a right triangle. The first way we solved for those in the previous unit is we used the Pythagorean theorem, and that's what we're going to do here. In this case, 20, this side, my hypotenuse, is going to be C. It's across from that right angle. And I can proceed like I did in the last unit. I can subtract 144. And then to cancel out this squared, remember you need to square root both sides. And so question mark ends up being the square root of 256. Let's check and see if that is a perfect square. When I square root 256, I get 16, and so I'm actually going to say that that missing piece, that tangent, is 16. So whenever I see a tangent and it's interacting with a diameter or a radius, so here it's interacting with this diameter, I know I get a right angle, and so I have a right triangle here, so I can find this missing piece using Pythagorean theorem. Question mark is my hypotenuse, so it's over here in place of C. One of my sides is 7.8. And then this whole side is this one radius plus this other radius. So this other radius is 5.2. So that means the whole thing is 10.4. And so I can go ahead and put these in the calculator. 10.4 squared. 108.16. 7.8 squared is 60.84. The squared stays on my question mark because I haven't done anything to that yet. I can add those things together. And get 169. Then I'm going to square root both sides because I want to cancel out the squared on question mark. And the square root of 169, you could put this into your calculator, you will get that it's 13. If it comes out to be a decimal, then we'll just leave it in the radical form. So I want you to give this one a try. Use your newfound knowledge of tangents and diameters and tangents and radii and your previously obtained knowledge of Pythagorean theorem and find the missing side here. When you're done, press play and check your answer. So hopefully you were able to set this up. Question mark is the hypotenuse. My right angle is right there between my tangent and my diameter. No need to double the radius or anything. We know how long the diameter is here. The square root of 289 is 17, so we should actually say it as 17. Of course, if you have questions about this, please do ask. Make sure you watch all the way to the end here because I do have some questions I want you to answer based on these 4 circles. As always, please ask for help. Please do some practice when you're done with this because it's the practice that reinforces these ideas and makes them something that you remember and that are easier for you than they were before we started. Take your time, ask for help. Good luck.